Alright, in this video we're going to be looking at equations, and we're going to look at properties of equalities and applications that involve equations. First of all, we'll discuss some of the properties of equality. There are a couple of them. One of them is the addition property of equality, and that is for any real numbers a, b, and c, if a is equal to b, then a plus c is equal to b plus c. In other words, if a is equal to b, the left side and the right side are equal, then I can add the same non-zero number to both sides of the equation, and I will get a true equality. Now for the multiplication property of equality, here if a is equal to b, then a times c is equal to b times c. In other words, if both sides of the equation is true, then I can multiply the same non-zero number on both sides of the equation and come up with a true statement or true equality. Then you have the cancellation properties of equality. In this case here, if you have a plus c is equal to b plus c, then I can say that a is equal to b. In other words, I can subtract the same non-zero number on both sides of the equation in order to get a is equal to b, which is here the converse of the addition property of equality. And the other one is the converse for the multiplication property of equality. If a times c is equal to b times c, then I can divide both sides of this equation by c to come up with a equaling to b. And then you have your addition and subtraction properties of equations, where you can add and in this case if a is equal to b and c is equal to d, then you can add a plus c and b plus d, and they'll both be equal to each other. Also, a minus c and b minus d will be the same. When we're solving equations, we can think of this as using the balanced scale model, which is an excellent way to understand the basic concepts used in solving equations and inequalities. And equations can be explored using a balanced scale. What inequalities does, it tilts the scale. With equations, we know that the left side and the right side have to be the same, so they balance. So if the pan on the left side is released, then the scale will tilt down on the right side. And when that happens, we have an inequality. So if you have something heavier on the left side, on one side of the scale, it's going to tilt down. So that means that one side is heavier than the other. That means we have an inequality. And if the pan on the left is released, the scale will balance, which means we have an equality. That means that the left side is equal to whatever is on the right side. And here we want to find some solutions for the variables that will keep the scale balanced. Like in this case here, you have 3 times some box equal to 2 times some triangle. Okay, so here if I let the square equal to 2 and the triangle equal to 3, the scale will be balanced. Also, if I let the square be 4 and the triangle be 6, that too will keep the scale balanced. So these are some solutions for the variables that will keep that scale balanced. Okay, now let's say we want to solve for x. Here we got an equation 3x minus 14 is equal to 1. Now write this off to the side. 3x minus 14 is equal to 1. Now here they use the scale to illustrate this situation. Okay? Now what we want to do here, we want to keep the scale balanced by finding out what x is. Well, one suggestion is to add 14 on each side of the equation. So in this case here, if I'm subtracting 14, the opposite would be adding 14. But if I add 14 on the left side, I must add 14 on the right side. So when I do on one side of the scale, I have to do the same thing on the other side of the scale. That's where we use the addition property of equality here. Okay, and then from here, subtracting and adding 14 is the same as adding 0, so you'll be left with just simply 3x. That's equal to 1 plus 14 will be 15. So in this case, you're going to have 3x is equal to 15, which remains a balanced scale. But we want to solve for x. Okay, in this case here, x is being multiplied by 3, so the opposite of multiplying by 3 is dividing by 3. So we need to divide the left side and the right side by 3. Okay, because whatever we do on one side of the equation, we must do the same thing on the other side. So x will be equal to 15 divided by 3 will be 5. The 3x divided by 3, you divide out the 3, you're going to be left with x. And this is where they use the cancellation property of equality to get x is equal to 5. So the solution, or the value of x for this particular equation, would be x equal to 5. And here's some examples of just this. Solve each of the following for x. In part A, you got x is equal to the cube root of 4. X plus the cube root of 4 is equal to 20. X plus the cube root of 4 is equal to 20. Now, to get the x by itself, we're adding the cube root of 4, so we need to subtract the cube root of 4 on both sides of this equation, as you can see here. So that means if we add the cube root of 4 and subtract the cube root of 4, we're going to get 0. So that leaves us with x, and we will just leave this as just simply 20 minus the cube root of 4. And then in part B, you got 3x is equal to x plus the square root of 10. In this case here, we got the x, the variable, on both sides of the equation. What we want to do here is get the x's on one side of the equation. It'll be easier to move the x over to where the 3x is, and we're going to do that by subtracting x on both sides of this equation. So on the left side, you got 3x minus 1x. That's 2x. Adding and subtracting x is the same as adding 0, so the x's will give us the sum of 0. You're left with the square root of 10. So you have 2x equal to the square root of 10. Now to solve for x, we're multiplying by 2, so we need to divide both sides by 2. So that'll be x is equal to, now you want to be careful here because you don't want to say the square root of 10. You don't want to say square root of 10 divided by 2 will give us the square root of 5. That's not the case. It's simply just rewriting it as just the square root of 10 on top, and then the 2 will be in your denominator. So it'll be the square root of 10 divided by 2. Part C, you got 4x plus 5x is equal to 99. Now, if you combine like terms here, you got 4x plus 5x, that's going to give you 9x equal to 99. And to get the x by itself, we're multiplying by 9, so you want to divide both sides of this equation by 9 to get x is equal to 11. And part D, you want to solve this one for x. You got 4 times the quantity x plus 3 plus 5 times the quantity x plus 3 is equal to 99. Okay, now I'm going to show you a different way of doing this particular type of problem here. What I would do is use a distributive property. What I would do is multiply 4 times x. That would give me 4x plus 4 times 3, which is 12. So I got 4x plus 12. And then I got 5 times x, which will be plus 5x. And then plus 5 times the plus 3 will be plus 15. That's equal to 99. Okay, on both of these, I'm using the distributive property. Now I can combine like terms here. Add 4x and 5x, you're going to get 9x. And then 12 plus 15, that'd be plus 27, and that's equal to 99. So we got 9x plus 27 is equal to 99. So now to get the 9x by itself, we'll simply subtract 27 on both sides. Since we're adding 27, the opposite of that will be subtracting 27. So now we'll just have 9x by itself because adding and subtracting 27 is the same as adding 0. And that's equal to, on the right side, 99 minus 27 would give us 72. So now 9x is equal to 72. Now, x is being multiplied by 9, so to get the x by itself, the opposite of multiplying by 9 will be dividing both sides of this equation by 9. So now you'll just have x is equal to 72 divided by 9 is 8. So here x equals 8 would be the solution to that linear equation. Okay, here's an application problem that deals with equations here. Let's talk about overdue books. Bruno has 5 books overdue at the library. The fine for overdue books is 10 cents a day per book. He remembers that he checked out an astronomy book a week before he checked out 4 novels. If his total fine was $8.70, how long was each book overdue? Okay. We see that Bruno has 5 books overdue. He has checked out an astronomy book 7 days earlier than the 4 novels. So the astronomy book is overdue 7 days more than the novels. The fine per day for each book is 10 cents. The total fine was $8.70. So we need to find out how many days each of those books were overdue. Now we're going to devise a plan by letting D be the number of days that each of the 4 books or the 4 novels was overdue. The astronomy book is overdue 7 days longer. So that will be D plus 7 days. That would be the algebraic expression for the number of days that the astronomy book was overdue, if we let D be the number of days that each of the 4 novels was overdue. The total fine was $8.70. Okay, so here the fine for each of the novels will be the fine per day times the number of overdue days, which is going to be 10 times D. Okay? Because it was 10 cents for each day it was overdue. So it'll be 10 times D. So the fine for the 4 novels, you have a day's fine for the novels times the number of overdue days. And the 4 comes from those 4 novels times 10D, which will be 40D. For the astronomy book, it'd be 10 cents times D plus 7. Okay? Because the D represents the number of days the novels were overdue plus 7 additional days. Because the astronomy book was overdue 7 days more or a week longer than the 4 novels were. So here we have the equation down here. 40D for the 4 novels plus 10 times the quantity D plus 7, that's equal to 870. So that would be the equation that we're going to use to find out how many days the books were overdue. Okay? So we solve this equation. Now here we use the distributive property here. We bring down the 40D, and then 10 times D, that's 10D, plus 10 times 7, that's 70. That's equal to 870. Then on the next line, we combine like terms here. 40D plus 10D is 50D. So you have 50D plus 70 is equal to 870. Then you're going to subtract 70 on both sides here. So here you're going to have 50D is equal to 870 minus 70. So 50D is going to equal 800. divide both sides by 50, you're going to get D is equal to 16. So each of the 4 novels was 16 days overdue. The astronomy book was 7 days overdue longer than the 4 novels, so you'll add 16 plus 7 to get 23 days overdue for the astronomy book. Okay, so this is how we use those word problems and translate them into equations to solve for a particular variable. And then the look back would be this: each of the 4 novels was 16 days overdue, and the astronomy book was 23 days overdue. Because the fine was 10 cents per day per book, the fine for each of the novels was 16 times 10 cents, or 160 cents, or $1.60 if you want to say it like that. So for the 4 novels, it'll be 160 cents times 4, or 640 cents, or $6.40. Then the fine for the astronomy book was 23 times 10 cents, or $2.30. Now add the $6.40 to the $2.30, you'll get $8.70. That agrees with the given information. Let's look at a newspaper delivery problem as an application of solving equations. In a small town, 3 children deliver all the newspapers. Abby delivers 3 times as many papers as Bob, and Connie delivers 13 more than Abby. If the 3 children delivered a total of 496 papers, how many papers does each deliver? Now, here the problem asks for the number of papers that each child delivers. It gives information that compares the number of papers that each child delivers as well as the total number of papers delivered in the town. So we're going to let A, B, and C be the number of papers delivered by Abby, Bob, and Connie, respectively. In this case, Abby delivered 3 times as many papers as Bob. So if we're letting B be the number of papers that Bob delivers, then A would be 3 times B. A is going to be the number of papers Abby delivered. Connie delivered 13 papers more than Abby. Well, A is represented by the number of papers that Abby delivered, so C, which is Connie's number of papers that she delivered, will be A plus 13. Then the total delivery is 496. So the number of papers that Abby delivered, which is A, plus the number of papers that Bob delivered, that's B, plus the number of papers that Connie delivered, which is C, that's going to equal to 496. Okay. Now in this case here, to reduce the number of variables, we're going to substitute 3B in for A. And that's in the second and third equations. So here C is equal to A plus 13. That means that C becomes, since 3B, A is equal to 3B, C is going to be equal to 3B plus 13. And then this equation A plus B plus C is equal to 496. Well, in this case here, we're substituting 3B in for A, so that's going to be 3B plus B plus C is equal to 496. Okay. Now here we're going to make an equation in one variable, which is going to be B, by substituting the 3B plus 13 for C in this equation here. And then we're going to solve that equation for B, and then for A, and then for C. And you'll see this on the next sheet here. When you substitute 3B plus 13 in for C in this equation here, you're going to get this right here. 3B plus B plus 3B plus 13 is equal to 496. That will be the equation that you'll use to solve for B, and then for A, and then for C. Now, combined like terms, 3B plus 1B plus 3B is 7B, plus the 13 is equal to 496. You're going to subtract 13 on both sides of this equation to get 7B is equal to 483. Then you need to divide both sides by 7 to get B is equal to 69. So, the number of papers that Bob delivered is 69. Now we need to find out the number of papers that Abby delivered. In this case, A is equal to 3B. That's the number of papers that Abby delivered. That's 3 times B. Well, B is 69, so 3 times 69, we just replace the B with 69 in that particular expression to get 207. So Abby delivered 207 papers. And for the number of papers that Connie delivered, it was 13 more than Abby, so it's A plus 13. Well, Abby delivered 207, so it'll be 207 plus 13, which would give you 220. So Connie delivered 220 papers. So in this case here, Abby delivered 207 papers, Bob delivered 69 papers, and Connie delivered 220 papers. Now, the look back would be this. The information in the first sentence, Abby delivered 3 times as many papers as Bob, check, since 207 does equal to 3 times 69. The second sentence, Connie delivered 13 more papers than Abby, is also true because 220 is the same as 207 plus 13. And the information on the total delivery check, since you add 207 plus 69 plus 220, that would give you a grand total of 496 papers that were delivered by all three. And that would conclude this particular section on equations.